Okay, she might close the door. By the way, this PowerPoint, we saw this yesterday, but this PowerPoint's wrong. They either said the wrong question, but we calculated yesterday that it was 112. Because it's asking how much water is required to dissolve 100 grams. 89 is not. That's how many grams dissolve in 100 grams of water. Looking at the left, solubility is how much dissolves water. So reading solubility curves. So let's do some more practice problems. How much potassium chloride will dissolve in 100 grams of water at 50 degrees Celsius? So go up from 50. And we look over. 42 is what we said. 42, 43. All right. See if I can work. Hang on. So solubility solubility is the maximum amount of solute that will dissolve, and typically we do in 100 grams of water. We usually let it be 100 grams of water. Another thing you could say is just solvent. Without context, we usually refer a solubility refers to 100 grams of water. So your water bottles have 500 grams of water in them, 500 milliliters water bottle. So how much salt will dissolve in 500 grams of water that's at room temperature? And what? Oh, amazing. 2023. So room temperature is defined as 70 degrees Fahrenheit in Celsius, or 20 degrees Celsius. So 20 degrees Celsius is 68 degrees Fahrenheit. So we'll use 20 degrees Celsius. So how much salt could you put in a water bottle and have it dissolve, all dissolve? So what is table salt? Have y'all memorized the formula? So that's sodium chloride. So that's blue line. So it's 20 degrees. And over, what is that, about 35? So we know that 35 grams sodium chloride per 100 grams water. So we can do a related rate problem. We know it's 35 grams of salt per 100 grams of water. And this ratio is going to stay constant. This is the ratio of maximum grams that can dissolve to water. So this is a ratio of a solute to solvent. This ratio is going to stay constant. So if we change it to 500 grams, then we need to figure out how much grams of sodium will dissolve. So cross multiply that. Has equal this. This is being multiplied on this side. So to move it over, we would divide. So to get rid of this, being multiplied, so to move it to the left side, we divide. Grams water cancels out with grams water, giving us grams of sodium chloride. So that's 35 times 500 divided by 100, or 35 times 5, gives us 175 grams of table salt. So that is the most, assuming it's pure water, that is the most salt you can put in a water bottle without it, while it's without it coming out of solution. So water bottle can dissolve at most that amount of salt. We can also see that temperature doesn't really affect salt concentration that much. If we were to reach about boiling point, so at boiling point, how much more salt, if we start boiling in water, how much more salt can we put in it? So at 100 degrees Celsius, about 40 grams per 100 grams of water. So at boiling point, 100 degrees Celsius, we have about 40 grams of salt per 100 grams of water. Doing the same thing we did, going to 500 grams of water, cross multiplying. I highly recommend you keep units in and cross them out to prevent you from making mistakes. I, of course, don't make mistakes. So cross multiplying 40 times 50, that would be 100 times x. Divide both sides by 100, that would be 40 times 5 equals x. That's 200 grams of sodium chloride, and this would be bar per 500 grams of water. So by increasing the temperature of the water to 100 degrees, so at 20 degrees Celsius, we can put in 175 grams of salt into 500 grams of water. And at 100 degrees Celsius, we could put in 200 grams. That means by raising the temperature from 20 to 100, we get an additional 25 grams to dissolve. Potassium chloride is actually a salt substitute. We'll see later in the year, potassium and sodium are very close and similar. They share a lot of the same properties. Potassium chloride is used as a food preservative. So is salt. You all know how they used to preserve meat? Yes, so they just cover it in salt, and that can preserve the meat. You can also use potassium chloride to do the same thing. But if you wanted to get something really salty, notice how much more salt potassium chloride you can add versus sodium chloride. We could also do similar problem. If I asked you instead, how much water? So at 100 degrees Celsius at boiling point, we know that at most 40 grams can dissolve into 100 grams of water. If I asked you instead, how much water you need to dissolve 200 grams of sodium chloride, we just move our x to where the water is. How much water do we need for 200 grams? And we just know this ratio. You could cross multiply, do the same thing. You wind up with 500. So 40 times x equals 100 times 200. X would then equal 100 times 200 divided by 40, and that gives you 500 grams of water. Does this make sense now to y'all? I felt like I wasn't explaining it too well yesterday for you guys. Fortunately, I don't have the other class, so I can't really continue today. I just wanted to make sure that this made more sense. I tried doing dimensional analysis, but it's confusing to explain it with dimensional analysis. It's better just to do cross multiplication. I also tried doing more algebra, where cross multiplication just makes a whole lot more sense. But I think that's where I'm going to do today. I just wanted to clear that up. That's it.